Hello and welcome to our webinar today. My name is Lance McCall, Global Campaign Manager here at Ribbon Communications, and I'm joined today by my expert panel of colleagues that you can see on the screen there. Would you guys like to go ahead and introduce yourselves?
So, hello, my name is David Stokes, and I'm in Portfolio Marketing at Ribbon, and I have responsibility for ECI packet-based solutions within that Ribbon portfolio.
Hi, I'm Jonathan Homa, also coming from the ECI side of the house, where I'm responsible for our optical networking solutions as well as our SDN control solutions.
And hello, I am Sam Lyle. I am the Director of Business Development for Packet Optical Things at Ribbon and ECI, and I'm based in Dallas, Texas.
Well, thank you all for joining today. Before we get started and kick it off with David Stokes, I did want to mention the Ask a Question box. It's at the bottom right of your screen. If you don't see that box, there should be a question mark on the right side of your interface. Just click that question mark and it should expand the questions tab. We'd love to hear from you during the webinar today, so please reach out, ask us any questions that may come to mind as we go through the material. And we'll do a little Q&A towards the end of the webinar. And with that, I'll go ahead and turn it all over to David.
Thank you, Lance. And firstly, I'd like to say how pleased we are to have the opportunity to introduce you to our packet and optical networking solutions. It's really quite exciting for us what this brings to the combined Ribbon portfolio. So when we look, most of you probably know, Ribbon and ECI completed the merger a few months ago now. And as you probably know, we're now merged as one team and trading on the NASDAQ. This larger company is now much better able to serve our larger customers and our smaller customers with a combined set of communication solutions for both voice and for data. As a combined company, we provide solutions to the majority of the major service providers in the world, and you can see some of the logos shown here. We also have a strong presence in enterprises, independent network operators, and national research and education networks, NRENs. And we provide mission-critical communication solutions to utilities, oil, gas and water, transportation, road, rail, air and sea, government, and even to defence networks. And if I can make the slide turn, we do well. With our combined portfolio, our solutions can now be seen end-to-end across the networks that we supply to our customers, providing them with a complete set of telecom services. And today, we'll be focusing on that oblong in the middle. We're focusing on our packet and optical transport solutions. So let's start by Let's start by focusing on the changes that are forcing you to change your networks and how that impacts the packet and optical transport network. Business services are moving into the cloud. This requires reliable, high bandwidth connectivity. Residential customers are looking for massively increased bandwidth, and gamers, a special set of these residential customers, want this high bandwidth with low latency and high reliability, but they are willing to pay for it. And we are also at the start, as I'm sure you're aware, of the 5G era, with its massive uplifting capacity and connectivity to support initially enhanced mobile broadband services, but not far down the line, we'll see the need for a new type of sliced mobile transport infrastructure able to deliver highly deterministic performance at ultra low latency with ultra high reliability. And of course, not forgetting the massive IoT and IIoT connectivity that we're required as we move to become smart. Think smart grid, smart buildings, smart cities, in fact, smart everything. To support this capacity and connectivity, fiber is being deployed deeper and deeper into the network, whether this be the fiber deep challenges being applied to MSOs, or the rush to deploy fiber to the home, fiber to the business, being supported by the various government initiatives we are seeing in every country in the world. In the midst of this, the threat from OTTs and malicious hackers is ever on the increase. I'm not deliberately tying OTT people up with hackers. They're just people attacking your networks or your profitability. And finally, I don't know about you, but the current situation we're all in is making me rethink my communications needs, priorities, and spend. For me, reliable, high-capacity, low-latency broadband is becoming incredibly important. It's allowing me to actually continue working while I'm at home. And as I assess my spend for the next 12 to 18 months, me as an individual, making sure I have a reliable broadband network with all the applications and services I want on that network is far more important than the $400 or $500 required to upgrade my iPhone, for example. So I think we'll start to see, both for individuals and for businesses, some reprioritization of spend around good broadband connectivity. So with all these moving parts, communication service providers need a network that is able to evolve when and where required. And at ECI, we launched our elastic network strategy a couple of years ago with the purpose of providing customers with a solution that is agile enough to allow them to introduce and deploy new services as and when they're required, provide real-time autonomous monitoring and control of their network, and operate in a true multi-vendor ecosystem that is the reality of today's network environments. So a bit more focus on that packet and optical network and where we fit. With our combined portfolios, our solutions can now be, our solutions are flexible enough to provide packet and optical solutions to the network challenges experienced, as I mentioned before. For example, we're one of the leaders in providing mobile backhaul transport for 4G, and we now have a fully featured solution for 5G that very few others can match. With our 5G hybrid slicing approach, the network can be sliced using multiple optical and packet techniques. This allows the right slicing approach to be taken for each supported service type. Great for MNOs supporting multiple services, but it is also great for organizations wishing to wholesale connectivity to these MNOs. And for a couple of decades now, we have been the leaders in providing deterministic packet transport required to deliver mission-critical services. This needed deterministic packet transport becomes more important as businesses export more and more of their business-critical applications to the cloud, as gamers demand and are willing to pay for low latency, and of course as 5G evolves to support more advanced services. And allied to that, bolted onto that, we have a world-class optical transport solution that is highly successful in NRENs and communications service providers alike, which my colleague Jonathan Homer will now talk to you about.
Thank you very much, David. And if you can go to the first slide in our optical networking solutions. Our optical networking solutions are based on our Apollo optical networking family, and they're controlled by our Muse control and network management system. Apollo provides a complete solution from the access to the core for multiple applications, as we will see. It's supreme in providing you as service providers with many choices so that you can assemble optical networks in a fashion that's tailor-made to your particular needs. This is based on a set of powerful transmission capabilities that range from 10G to 600G, a complete ROADM solution featuring all the latest and greatest in colorless, directionless, contentionless, and flexible grid, and a complete product line for OTN switching that spans all the way from the access to the core. Most important, Apollo can be controlled dynamically from ECI's Muse platform. This is our network management and control platform, or through or via third-party software if you're using a third-party optical domain controller using standard interfaces. And this will enable you to create your own bandwidth on demand applications or dynamic restoration applications by exercising Apollo yourself. Next slide, please. So among Apollo's major strengths is its flexibility. Apollo, as you see in this diagram here, can be applied to a broad range of applications and topologies all the way from the access, which typically features rings, through the metro, which uses mesh, to regional on long haul, which requires long haul links. So it can be applied to a whole variety of topologies. And it's able in this way to extend optical connectivity from small areas, say in a metro environment, across regions, even across countries. So let's start examining some of the applications that Apollo can provide you as a service provider. Next slide, please. So today we'll be examining 6 key applications. These are optical aggregation, optical backbone, an end-to-end optical network which combines these two and has some unique values. A special case of optical aggregation which is called Layer 1 business services delivered by an OTN switch network, a carrier of carrier application, and a wide area data center interconnect application where we consider ourselves having the best 400 gigabit Ethernet transport in the business. So optical aggregation, I'm sorry, slide please, David. Optical aggregation is a logical place to start. This application is responsible for aggregating many lower speed interfaces into a smaller number of wavelengths for cost-effective transport. So rather than having to transport every single service individually, what you can do is aggregate many of them onto an individual wavelength. Apollo has multiple values here. First and foremost, it supports a wide variety of services or client interfaces. Notably, it supports gigabit Ethernet, all the way from 1 gigabit Ethernet all the way to 400 gigabit Ethernet. It also supports other very important services such as fiber channel, again here the full range from fiber channel 1 to fiber channel 32, as well as legacy types of optical transport services such as SDH and SONET, as well as miscellaneous video services. On top of that, it also has a capability to encrypt each of these services individually. So you're not necessarily encrypting the whole wavelength, we can do that, but you can also encrypt individual services selectively. We also know that when we're talking about aggregation networks, density and power and cost rule, and our platforms are optimized for delivering solutions that can deliver high density, low power, and very effective costs. The predominant technology or topology, I'm sorry, for optical aggregations is rings. And Apollo supports this with ROADMs that allow full wavelengths to pass through multiple nodes, and we can give you examples of passing through tens of nodes at an all-optical level without adding any cost. It also supports multiple protection options for this particular architecture, so in case a ring breaks, for instance, it's able to route traffic in the alternate direction. And all of management of optical networking, including provisioning, maintenance, monitoring, control over dynamic restoration, is monitored through a single pane of glass through our Muse control system. Next slide, please, David. So an optical backbone is responsible for routing the traffic that's been aggregated by the aggregated network and for transmitting this traffic among core network nodes. Now, it's a separate application because in some cases, of course, the aggregation is not done at the optical layer. Depending on your network, it may be done at the packet layer, in which case the optical backbone is picking up already aggregated traffic, usually, say, at about 100G links from the packet networks. But as you'll see in the next slide, which we'll get into later, it could also interwork seamlessly with the aggregation network. So while density and power optimized solutions are important in the aggregation network, they continue to be important here in the optical backbone. However, the optical backbone also has an additional requirement where many of our customers demand the highest level of transmission performance. And Apollo is able to deliver this very high level of transmission performance, and I'll show some examples of how we rate among our competitors in this particular area a bit later on in the presentation. But we do this using a programmable transmission technique that's able to deliver the maximum capacity for any distance. Besides routing traffic, whether it's power and density optimized or performance optimized, you have a range of OTN switches, and again, fully featured CDCF ROADMs to best fit your particular networking needs. Moreover, by deploying these ROADMs or OTN switches, you could also exercise high availability architectures such as WSON or ASON, which is able to dynamically reconfigure the networks at a wavelength or at a service level to provide backup. And again, without mentioning, everything managed through a single pane of glass. Next slide, please. So when Apollo delivers a combined solution, both an aggregation and a backbone network, it's in a position to deliver truly unique and exceptional end-to-end values. For instance, it can seamlessly aggregate both all the services in the most efficient manner so that you really guarantee to have a minimum number of wavelengths throughout your network, and at the same time, because we're engineering these wavelengths end-to-end from the service to its destination, say from an enterprise to a data center, we're able to provide optimal end-to-end optical performance for these minimum number of wavelengths. So really what you're looking at is possibly the lowest cost type of optical solution when you're looking at an integrated solution coming from using ECI's Apollo technology. It also puts our technology in the best position to deliver end-to-end service and network availability guarantees, again, using the types of ASON and WSON architectures that I mentioned before. It also puts us in a position to deliver additional or value-added services, such as bandwidth on-demand services, again, coming from the endpoint destinations, again, often enterprises, and enabling them to turn up bandwidth to higher degrees when it is needed for a variety of applications, something we'd love to talk to you about. Next slide, please. Layer 1 business services. As I mentioned when I was going through these services, this is a unique case of service aggregation and transport. It focuses on an ability to rapidly provision Layer 1 services to businesses where it is particularly important to be able to turn up these services quickly. A lot of times these businesses will call up you as a service provider. They say we want a 1 gigabit or a 10 gigabit Ethernet service or a storage area networking services connecting, say, their headquarters to a data center, and they're really not in the mood to wait 2 or 3 weeks or even 2 or 3 days to get the service. They'd like to have it turned up within a day or two. With Layer 1 business services, you can do that. And this is built on pre-engineering wavelengths to a number of strategic locations, say a business park or sort of large campuses, and then using OTN switching that extends to the edge of the network, which all you have to do is just hook up the gray interfaces to these edge OTN switches, and voila, you have a capability to turn on a service and route this end-to-end through the OTN switch network in an extremely rapid fashion. So this really provides maximum grooming and provisioning flexibility from the access to the core with a number of mechanisms for providing high availability guarantee for these services. Again, something Tier 1 and Tier 2 service providers really like. Next slide, please. A carrier of carriers is where a network operator leases a portion of their optical network to another operator. The typical scenario here is where the leasing operator needs to serve a certain geographic area, and it's easiest to do so by using someone else's facilities rather than deploy their own network into that area and sort of compete head-on on a facilities basis. Many more people are trying to monetize and maximize the value of their optical network by, again, leasing capabilities to other carriers, sometimes partners, but sometimes just on an arm's length business relationship. Apollo enables doing this through its sophisticated ROADMs that can carry alien wavelengths, which is, you probably know, is the industry term for third-party wavelengths. We've been leaders in this capability for many years. And we can even monitor these third-party wavelengths through our monitoring systems. So in other words, you have full visibility on the traffic that you're carrying. And a new capability that's being added to Apollo, which really brings us to the next level, is something called spectrum sharing. We're not just providing alien wavelengths, but you could actually provide entire swaths of spectrum to another party, and they can engineer wavelengths on that spectrum as they wish, all manageable through their own customer network management portal. Next slide. The last application I'm highlighting today is DCI, or Data Center Interconnect, particularly applied to what we call wide area DCI. So Apollo is very well suited to enabling service providers to deliver wide area DCI services to enterprises and in particular co-location data centers, in particular for storage area networking among sites for data replication and backup purposes. In particular, because in most cases very high bandwidth is required over here. One of the new client interfaces that is coming out right now is a big jump from 100 gigabit Ethernet to 400 gigabit Ethernet, and we support a real leading edge solution, 400 gigabit Ethernet transport, that I will say notably can even be applied to brownfield networks, something most of our competitors cannot do. Apollo's flexibility also enables turning up high bandwidth connections very quickly and using a variety of mechanisms to again extend service level guarantees for this wide area DCI. Moreover, this application highlights Apollo's ability to provide layer 1 optical encryption. This protects optical links against snooping via fiber tapping, and it provides comfort to enterprises that their data flowing over the wide area networks is secure. Next slide, David. So in the last few slides, we have identified several applications of what Apollo can do for you. Now in the next slides, I'm going to explore why you should choose Apollo. An essential value that Apollo provides is choice. Here we see how Apollo provides choice for optical transmission. The first choice I highlight on the left part of the slide is optimized for performance, what we call performance optimized transmission. This extracts the maximum capacity for any distance and fiber condition. When you need the maximum speed or capacity on a given wavelength between 2 points, such as say connecting 2 data centers over a particular distance, this is the kind of solution you should choose. The second approach is optimized for density and power, while it does deliver performance that is strong enough for most applications. And in fact, when we look at networks, while customers do deploy performance optimized solutions, for the greater part in most of their networks, they employ the density and power optimized. But having the mix of both is extremely important. So the density and power optimized makes use of industry standard pluggable transport technologies. ECI is already on the 3rd generation of our solution in this particular domain, where we've been employing these pluggable technologies from day one. And what it enables you as a service provider customer to do is upgrade very easily to new, faster generations of these pluggables as they become available within the same form factor. Next slide, please. So I've made some claims until now that ECI technology through Apollo has a leading edge performance, a high performance or performance optimized solution. So you're going to say, well, Jonathan, we've been hearing a lot of announcements from some of your competitors about solutions that deliver 800G. And if you ask, what are we delivering? And on a single carrier, we're actually delivering from 100G to 600G. But that's just taking a flat out look at what you do on a single carrier and not at the architecture of the high performance solution. So the real way to look at the solution is what you can deliver in a single channel. And yes, while our competition is delivering a solution using 800G, it's also a very inflexible solution. And in fact, it's constrained to a channel bandwidth of over 100 gigahertz, specifically 112.5 gigahertz. We have a very flexible solution where we can put 2 carriers together in the same channel and have these work in tandem. And again, each one of these could extend from 100G to 600G. And this provides you, as I'll show in the next chart, performance advantages in terms of practical transport that you don't get with a single carrier. I like to compare this to a speedboat. You have a speedboat, for instance, with one very big, powerful engine, but it only works at a single speed. Or you have a speedboat with two just regular powerful engines, but they can work together in tandem and have a great degree of flexibility associated with them. So what does this mean? Next slide, please. So the practical result is that two carriers in a single channel, and I do emphasize in a single channel, is better than one. We look at this for two particular scenarios, and again, versus a major competitor or major competitors that have the single channel 800G solution. So when you're looking at brownfield networks, and I'm pretty sure that all of you people listening on this call have brownfield networks, and you want to think about how you can maximize throughput on these brownfield networks, and here I mean 50 gigahertz or 100 gigahertz networks, with our solution, we can transport a single 400 gigabit Ethernet client for about 1,000 kilometers, or again, using the same solution, two 400 gigabit Ethernet clients about 200 kilometers. When you're looking at greenfield scenarios, here you need to compare both at our preferred single channel bandwidth of 150 gigahertz or the competitor bandwidth of 112.5. When you're looking at our particular solution, we can provide a transport of about 800 kilometers for two 400 gigabit Ethernet clients, while our competition is constrained to roughly half that distance. We can even go 400 gigabit Ethernet clients for about 120 kilometers, while our competition cannot do that. They have no capability in the same solution for bringing 400 gigabit Ethernet clients. When we compare sort of on their playing field of 112.5, the performance is roughly equal. Maybe they have a marginally better solution, so while we're claiming 275 kilometers, maybe they can go 325. And I should add, these numbers, by the way, are not hero experiments. These numbers are based on real fiber conditions, standard amplification, and taking into account at least 3 dB insertion loss for end-of-life purposes. So claims and marketing of sort of 800G is one thing. What you can practically carry from a 400 gigabit Ethernet client transfer point of view is quite another. And in this case, I'd be glad to talk with you or have our experts talk with you about this solution in great detail. We do have a better solution. Next slide, please. In the next few slides, I'll just be giving some snapshots of some of our capabilities in some of the areas that I've mentioned before. So here's a snapshot of what Apollo can bring to the table on the ROADM front. Again, emphasizing choice, Apollo can deliver from low degree to high degree ROADM nodes with virtually any combination of colorless, directionless, or contentionless add-drop capabilities, supporting both economical broadcast and select and very high performance route and select architectures. On the right-hand side, I highlight a few of Apollo's ROADM modules. I'm not going to go through all of these. Just two to mention. There's a ultra-compact 4-degree module that is ideal for aggregation rings. It supports integrated amplifiers, again, showing a proof point for our density and power optimized solutions. And at the high end, the third module down from the top is a true contentionless collector based on a combination of LCOS and MEMS technologies that allows adding and dropping multiple wavelengths on the same color. And because it features these two technologies together, its main advantage is it has very, very low insertion loss compared to the previous generations of contentionless add-drop that was available. So basically, the message I want you to take is, if you need ROADMs, we have the configuration that suits your needs. Next slide. So while ROADMs are the best method to route wavelengths without electronic conversion, OTN switching offers ultimate flexibility for grooming services onto a minimum number of wavelengths. And also, because you can map services onto pre-provisioned wavelengths, it's a perfect tool for providing applications like Layer 1 or rapid provisioning of Layer 1 business services. What I just want to illustrate here is that we have a complete access to core solution, all the way from the edge of the network, through the metro rings, through the core itself, so we can provide you the right size OTN switching for whatever your particular needs are. And as I'll show in some use cases, this can work seamlessly together with ROADM solutions. So it's not an either-or ROADMs or OTN switching. It can be ROADMs and OTN switching. Next slide, please. In the last few slides, we've shown how Apollo can aggregate and transmit and route wavelengths through a network. Apollo is also supreme for monitoring its own performance. Here we use the LightPulse application. This is based on integrated monitoring within the Apollo node. So in other words, you do not need additional equipment or additional blades. This monitoring is built into our amplifiers and our transmission and ROADM modules. And all the data is collected, and you get deep insights into the network through the LightPulse application for optical power, OSNR, and other parameters. And it particularly features trend analysis. So you can take a snapshot of your network or of your wavelengths and then compare that a month later, and you can begin to see if there's degradations taking place so that you could address these before they become service affecting. Next slide. Apollo also offers you as service providers customer freedom with an ability to create disaggregated solutions by assembling optical networks with major subsystems from multiple vendors. Obviously, like any supplier, we'd like to sell you an integrated solution, but we have the ability to respond to requests from service providers to procure Apollo subsystems individually. And this covers OTN transport, OTN switching, and ROADM line systems. Each subsystem is controllable via open standard interfaces, and it enables you to extract the maximum value from Apollo as you see fit for your network. We show a real commitment to this through our participation in the Open ROADM Forum that AT&T is driving. And as part of this activity, in fact, we recently demonstrated not only control of an OTN switch by a third-party controller, we also demonstrated interworking of our Apollo OTN switch at the data plane level or at the optical level with a Sienna muxponder. So in other words, showing that we're actually able to send and receive signals and interwork at the optical level. So we do support disaggregated solutions. Next slide. In these next few slides, before I wrap up this section, I want to provide some proof points or some demonstration for some of the capabilities that I've mentioned before and how these are applied in customer networks. For a few of these, I cannot mention the name of the customer because they have not been announced yet, but I can talk about the customer in general terms. This is a European-based global service provider with multiple international locations. Our solution supplies them with high-speed rings within metropolitan areas, primarily as a backbone for transport of enterprise services. It's a 100G, 200G flexible grid network that we are now in the process of expanding to 400G with several unique capabilities such as direct support within Apollo. That's a capability I haven't highlighted before for providing layer 2 carrier Ethernet services. Some of the reasons that ECI was selected by this customer is the high density and low power consumption solutions that I mentioned before that the customer was able to see directly as total cost of operation benefits. Even though it's primarily a ROADM network, there is strategic use of OTN switches that the customer has used both for aggregation and for support of a submarine link. And we also support, because in some of these locations it's not conventional central offices but data centers, and we do support platforms that can be configured for data centers and the airflow requirements that are required for data center equipment. Next slide. Here is an example of a US service provider where a major part of their business is leasing mobile backhaul transport to mobile operators. In other words, they provide transport between cell sites in the mobile switching center. Their particular challenge was handling traffic growth from 1G to 10G where their MPLS network, or their core MPLS network, not an ECI solution, but from another party, did not scale efficiently to handle that. So what ECI did is provide a transparent layer 1 transport that consolidates the lower speed, well, growing lower speed mobile traffic between the Ethernet demarcation points in a very economical fashion, again, using an OTN network, and hands them off to the mobile switching center in 100G links. And the last use case I'll mention, next slide. This is the customer that we actually have announced, ECI Telecom. And I selected this particular customer because it illustrates perfectly how Apollo delivers both optical aggregation as well as an optical backbone network together. By the way, JT claims to have been the first jurisdiction in the world with 100% fiber connectivity to all their business and residential premise customers. What Apollo does is it aggregates higher bandwidth traffic using transponders, but it uses OTN switches to aggregate multiple low-speed services along the lines of the layer 1 business services that I mentioned before. And all of this traffic is mapped onto DWDM fires via colorless and directionless ROADMs to create the optical backbone. And one other capability worth mentioning is this is part of the Light Pulse monitoring solution, is OTDR, optical time domain reflectrometry, that JT has actually used several times already to quickly locate fiber breaks that have occurred in their networks with amazing accuracy. So in these use cases, I hope I provided some insights into how some of our customers and hopefully yourselves can think of deploying Apollo. Next slide. So this closes the optical networking section. We have shown you three things. How Apollo can add value to your network for a variety of applications, how Apollo has unique capabilities for transmission, for wavelength routing, performance monitoring, and support of disaggregated solutions. And we've given you some real customer success stories providing proof to these claims how Apollo is being used. So hopefully we've given you some food for thought about how Apollo can be used in your network. And now I'm going to hand the presentation back to David.
So thank you, Jonathan, and thanks very much for that very informative section on optical. And I'll now spend 5-10 minutes talking about the packet part of our portfolio. And then we'll have time for question and answers at the end. So Neptune is the name for our portfolio of products optimized for packet transport. As I mentioned right at the start, our key values are that we are a leader in providing deterministic packet. We are a true global expert in providing all packet mobile backhaul type solutions. And that solution is used both by the MNOs and by transport network operators and others who are wholesaling mobile backhaul to those MNOs. And by using our expertise in both the deterministic packet and the mobile backhaul, we've been able to offer a comprehensive 5G transport solution today. And by the way, much of that technology for that transport network, because that is probably the most advanced transport network that's around at the moment, much of the technology that's developed for 5G is actually directly applicable to non-mobile applications, and I'll expand on this a bit later on. In addition, built into the Neptune functions and capabilities, we have just the right amount of optical stuff that allows interworking with the optical layer to be quite seamless. So things like OTN mapping, colored interface, etc., really facilitate good interworking between the optical layer and the packet layer. And finally, with our unique elastic MPLS capabilities, we provide true multi-service type capabilities to our networks. So with this elastic MPLS type capabilities, Neptune, as I said, gives you the ability to service many different types of market by supporting many different types of service. And you can support those markets with the right transport technology, technology for them. This allows you to deploy one network for all your services. Basically, with elastic MPLS, you can support maybe carrier Ethernet for one customer, or it might be a deterministic packet transport that is required to support business and mission critical services. Currently, this is provided by MPLS TP, and in the near future, this is supported by segment routing traffic engineered. Or it might be the dynamic packet transport they needed that's provided by IP MPLS for today's virtual private networks, VPNs. And by the way, these deterministic and dynamic domains can be stitched together where this makes operational sense. So this elastic MPLS capabilities in Neptune gives you the ability to easily support all of these different types of service capabilities. In addition, By using circuit emulation along with deterministic packet transport, you're able to easily migrate legacy TDM services, SDH Sonnet, and in fact give a performance which, if you select the PDUs to the right level, will give actually better performance than the existing SDH Sonnet network. So really given a truly platform that can support both future needs, but also gives you finally that platform that can support you in rolling off those legacy type services. So if we look at where that would, where Neptune fits in the network, you can see that we have the ability for the Neptune to sort all these multiple different types of networks. As I said, with the transport technology, it is right for them. This allows you to deploy the network for one set of services and then use this same network to service the needs of other services, whether these be planned or opportunistic. So for example, you could deploy the network to provide transport for residential broadband, and you put the network out there in the right place. By the way, we just do the aggregation part. We don't do the GPON aggregation, the XDSL stuff. We aggregate all the traffic that's coming back in those residential services. But you put that network out there into the field, and an opportunity comes along where an MNO is desperate for connectivity to backhaul their 5G connectivity. So you actually then have these points of presence in the network, and you have the equipment that allows you to put those onto that network you've deployed for residential. So giving you a quick win in a highly lucrative field by having a multi-service platform. So realistically, the Neptune here allows this true multi-service nature, gives you opportunities to address multiple markets at the same time, and you just configure the transport network so it best suits the service being delivered. So let's look at that in a bit more detail. I'll cover three particular areas today. I mean, there are many, many, many others, but let's focus on three, because I think they best highlight the capabilities that we have within our Neptune packet transport portfolio. The agile multi-service provided by our Elastic MPLS capabilities allows you, of course, to support the traditional MEF certified carrier Ethernet services, ELAN, E-Line, E-Tree, Access, etc., etc., etc. All certified. Our carrier Ethernet capabilities match the market needs in this space. And of course, we also provide the MPLS-based Layer 2 and Layer 3 VPNs. And all of this with the MACsec and IPsec capabilities that are required for these basic types of business services. But we also provide you, as I mentioned before, in these business service environments, with a platform that has the determinism and the circuit emulation required to migrate those legacy business services. So as you're going out there and putting a network in for the existing business services, the new business services, you can start to persuade your existing clients that they have a network that they can be confident in as they roll off the existing legacy business services based on Sonnet, etc. This really is quite important, as most of those legacy services are reaching end of life now, and you need this deterministic ability to do this whilst offering the whole gamut of business services as they exist today. And as we move into the near future, we start to see segment routing being more and more important. You can start offering more deterministic business critical type services where you can guarantee performance in a much more stringent way than we can today. In addition, our continuous innovation in our portfolio allows us to support the need for the bandwidth explosion we have already discussed. So for example, we have a T2U box called the MPT1250 that already supports 400 gigabit interfaces and 500 gigabit switching capacity. And by the end of next year, we're even looking to put 400 gigabit interfaces and 2 terabit switching into our 3U MPT1300 chassis. And as time evolves, you'll keep seeing these capacities being pushed further and further closer to the customer. As capacities grow, the network elements capacities must grow but they can't get bigger. There's a physical limitation. So our continuous innovation allows us to grow the capacity whilst maintaining our unique ability to provide determinism and multi-service. And of course, all of this is supported by a modern state-of-the-art intuitive network management system that provides you with all of the fault management and assurance that you require to rapidly deploy the network, but also to maintain it and ensure it is working efficiently and effectively. Then moving on to a second example. As I mentioned before, we've brought our expertise in mobile backhaul and leadership in deterministic packet transport together to create a 5G transport solution, which is available today. Our hybrid slicing techniques allow the right slicing techniques to be used for each service type. Moreover, these slicing techniques allow a single network to be partitioned to support different MNOs, with slicing providing the isolation between each operator. This ensures the performance of one network cannot impact the performance of another. So if someone's under capacity their network and they're really hitting it hard and it's slowing down, that won't impact the performance of the other network because we've got good isolation using slicing between those. And of course, in this sort of environment, each MNO that you're leasing to wants to see how their network is performing. So we provide the ability to use customer network management so they can manage their own networks. And again, there's isolation between these operational interfaces so that there can be no cross-seeing of what's going on in each other's network. Very important. And of course, with our leadership in deterministic packet, as I mentioned on the previous examples, we're able to provide the determinism required to support the more advanced ultra-low latency and reliability type services, LLC type services, as they become introduced into the network. So that's on the mobile backhaul. And the final quick example which highlights what we do in this part is I'll discuss the ability of our portfolio to support you in offering to provide operators of critical infrastructures, utilities, oil, gas, water, transportation, defence, government, etc., a managed communication service for connecting their operations technology, OT, and their IT networks. First and foremost, communications network for OT must be proven and it must be deterministic. These guys insist on proven technologies. Quite rightly so. These really are mission critical. If something goes wrong, things blow up, people die. So really, the technology has to be proven and it has to be deterministic. Our solution, as I think I've said enough times, is extremely deterministic. We're a leader in this. It is also extremely widely deployed and accepted in many, many mission-critical applications across the globe. But we're starting to see, for operational reasons, the need for these networks to start converging. So IT converging with OT, for example, or in the defence network, having a joint forces network where Army, Navy, Air Force all share a single network. However, they're absolutely, I'm terrified to be too strong a word, they're really concerned that one network might impact the ability of another network. So in a military type of defence network, if a ground forces army base gets infiltrated, they want to be able to make sure that nobody can jump between that network and the other. And again, this 5G technology I mentioned before, network slicing, this comes to the rescue. Basically, you can use the slicing to segregate between networks. You can run one joint network, but provide true isolation by segregating the network, each part of the network having its own slice. So 5G technologies are now being seen as extremely important in non-5G opportunities. And of course, our solutions also provide all of the OT security type mechanisms that are required to things like SCADA anomaly detection, IDS, IPS, etc. Have the extended temperature ranges required for critical infrastructures. All of this is table stakes in this area, and we have it widely deployed with many, many operational examples. So just to move on to a quick case study, I'll choose a mobile backhaul case study in a tier 1 operator that we had because it just pulls out a lot of the stuff I'm mentioning. And this was a major win for us in 2019, early 2019. The network was initially legacy TDM and MPLS TP, and they wanted to migrate over time to IP MPLS with an eventual migration path to 5G. The flexibility provided by our elastic MPLS on Neptune was key to winning this network. We could support the existing MPLS TP and legacy TDM domains and introduce new IP MPLS domains for the greenfield deployments. Then we have the ability to stitch between the MPLS TP domains and the IP MPLS domains, which allowed us to migrate the core of the network to IP MPLS while maintaining MPLS TP in the outlying domains. So you could run the circuit end-to-end across it, although it was running deterministic and dynamic IP. This allowed the operator, and continues to allow the operator, to choose the most appropriate time to migrate each of their MPLS TP domains. And of course, as I've mentioned previously, the deployed solution is easily evolvable to support 5G services as and when needed. One final point to mention about this particular network, or this particular operator, is they're pretty fiber poor. They don't have a lot of fiber. So as part of this solution, they also use DWDM to maximize the utilization of their fiber network. So I think, although this has been a really rapid trip through the packet transport capabilities, I hope you've seen that we are a strong advocate in supporting both dynamic but also deterministic packet transports. We have a lot of experience in mobile backhaul and how to take that determinism and experience in mobile backhaul to give you a solution which is 5G available today. But those techniques for 5G are usable well beyond 5G. Our solution with Elastic MPLS is inherently multi-service, and we provide integration, just the right level of integration and optical components to allow integration between packet and optical. So then moving on, just bringing this to conclusion, I think you can see from what both Jonathan has presented and what I've quickly gone over today around the packet area, that we have a world-class portfolio, world-class optical features, allied to leading capabilities in deterministic transport, multi-service packet transport capabilities. And I think you'll see that the world is moving more and more that way, that you need the ability to support mass transport, huge amounts of capacity in the network in the most efficient and effective way, the optical layer, and then to be able to move into a packet network that it becomes increasingly deterministic with the ability to guarantee latency and guarantee reliability and performance across the network. This is particularly true of 5G, but I think as we start to revisit what we want from our packet networks, we'll start to see the need to have increased determinism in those networks. Now, for example, gamers are quite happy to pay money for their services, but they want guaranteed latency. And it'd be absolutely amazing if a gamer could get better latency performance on a mobile network than they could on a residential fiber to the home network. But if you don't guarantee those performances, that's what will happen. So really need to start pulling these capabilities together. And then I think you can see that with this packet and optical transport capabilities, we now truly have the ability to offer, as Ribbon, a full set of communication services to the service providers and others. So voice and data together and combine to give a true service offering to the end user as a one-stop shop. And we can lever that with our long history of deployments in the world's largest service providers, as we identified at the start. The solutions now are becoming more and more cloud and application based. We have the abilities from the old Ribbon portfolio, given the cloud voice services, and the packet and optical services moving more and more software based with VNFs and NFVs, so true cloud and network solutions. And we have, I think, from going through this scenario in the packet optical, you'll see we've proven in solving the challenges faced by the mission and mission critical types of services and needs. So over the years between us, we have partnered with some really important customers, and every customer is important to us. It's important as to partner and help you grow your business. We listen to what you say and we react. So thank you very much for listening, and any questions?
Thank you so much, and Jonathan, and even Sam, who's been feverishly typing back there. We've had quite a few questions come in, so we want to address a couple of those. We have just a few minutes left. Maybe if you also could advance to the contact slides,
yes.
so that people can see that, and if they need to reach out, they have some people they can reach out to. But first question, why is deterministic packet transport so important? And I'll let anyone answer that.
I'll start there, and I think actually, I mean, it goes wider than deterministic packet transport. I think the deterministic transport, because the optical layer has a key role to play here as well. And I think traditionally this has been the realm of the critical infrastructures, where they have needed absolute ability to understand what's happening in their networks. But I think as time goes by, with 5G coming along and offering the URLLC type services, we'll start to see determinism becoming the norm, and then that will start to migrate back into the residential and business services as people like gamers are looking for guaranteed latency, and as more and more applications, business applications, move into the cloud, some of those will have strong latency, bandwidth and reliability requirements, and you will need to put the determinism in to achieve those.
Great. You mentioned layer 1 encryption. Can you talk more about Ribbon and ECI solution or offering for that and the importance of it?
Yeah, I sort of did mention that a couple of times in the applications, but I didn't have a separate slide on that when I went through the technologies. There was only so much I could cover. Layer 1 optical encryption is important. It's used by a number of our customers. I think some people say, why do I need layer 1 optical encryption? I can encrypt at the application layer. I can encrypt at the layer 2 MAC layer. The answer is it's very easy to tap an optical fiber. And when you tap an optical fiber, you have access to all the information flowing on that fiber. And even if some of the higher levels of the OSI's layers are encrypted, you have access, for instance, even if you're doing layer 2 encryption at the MAC layer, you still have that the actual addressing is not encrypted. So you can even get a complete insight into the network topologies and how all the MAC addresses are flowing and the types of traffic are flowing, which, between which locations. And then again, not always the layer 2 MAC levels are encoded, and then you can get access to even higher levels of information. So one of the advantages of layer 1 optical encryption is it doesn't add on any latency, so it doesn't affect the speed of the transmission. And with our solution, we have certain other advantages. We could enable you to selectively encrypt individual services. Even if there's multiple services on an individual wavelength, you can encrypt services individually. And this is a very nice offering when you as a service provider are extending connectivity services to enterprises, and they may want to, for instance, only have a value-added offering for particular services, but the other ones they don't care about. At the same time, what it enables you to do also, if you're extending this to enterprises, they could actually control the encryption keys themselves through a customer portal. So yeah, in a nutshell, that's some of the advantages of layer 1. Thanks.
Okay, great. Again, there's so many questions that came in. Here's one more. I think we probably might end on this one unless you guys see something else in the queue there you want to address. But the question was, can a third-party client be provisioned on Apollo only to monitor or see their circuit only? So example, service provider A leases capacity to client B. Is client B restricted to see their circuit only?
Yeah, of course. Through the if you're providing through a customer network management system, you could restrict the capabilities that a person has access to. So in other words, they do not have access to other people's wavelengths, for sure. I mean, they wouldn't have me any other way. I don't know if there's anything you want to add to that, Sam, or?
I think you may be on mute, Sam.
All right, I guess I will add one thing. We do have some nice capabilities that we call Light Pulse. And those Light Pulse software capabilities run on the Apollo line system. and they allow very easily third-party transponders and third-party clients to ride over that line system, and they can be, those wavelengths can be monitored and managed just like a native Apollo wavelength would be monitored and managed.
Okay, very good. Any other questions?
The last thing I would add then is, we didn't touch on security, and there is, which is of course a hot topic today for any solution, and security is a sort of imbued throughout our portfolio, both in terms of the control layers, the data plane layers, the physical security layers. We have a lot of information on that if people are interested. It's just something almost impossible to get into in a 1-hour webinar. But there's a fine degree of granularity, again, through the customer portals that are provided in terms of users and the capabilities that they have with multiple levels of protection. So again, come back to us and ask about security, and we'll talk to you for hours about that.
Yeah, I mean,
Sorry,
one thing to give us some idea of the intent of our security is that we've even put our 5G timing inside the MAC frame. And this was proven by an independent test house, ENTC, a couple of months ago. So yeah, the timing is inside the MAC frame, so you can't even infiltrate the 5G timing in that way. And we still meet Class C and Class D timing requirements with that. So you can see that security is really foremost in our thoughts as we build our solutions.